So in the chapter 8, we studied about the electric field, and in the chapter 9, we studied about the magnetic field. But we find out eventually the so-called electric magnetic wave is just a combination of the electric field and magnetic field. They are not separated. They are always together. So in order to understand them better about the electromagnetic wave, you need to know what is the concept and the properties of the wave. So we are going to first define what is the wave and how the wave is propagated. And we find out that we have a lot of examples in our daily life of waves, but they can be all categorized in terms of two. One is a transverse and the other one is longitudinal wave. So let's try to take a look about the examples of the wave. So when you throw the stone into the pond, you will see a wave propagate out from the center outward radially. This is the water wave. The wind will bring the flag moving. So this is another kind of example of the wave. When you speak, you produce the sound wave. And when you play the instrument, there's a vibration, and vibration will produce a sound, and you can hear that. Or it is simply in the stadium when you watch a game, you are doing the wave. So they are all the example of the wave. But most important, one of the most important example of the wave is the electromagnetic wave. So you have heard about all these different names: radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. So no matter which name you are talking about, they are all electromagnetic wave. It is just the different frequency of the electromagnetic waves. So in the following lecture, if I mention about the electromagnetic wave, I will simply just the EM wave. So you can see that the radio is the EM wave with a longer wavelength, and gamma ray is the EM wave with the shorter wavelength. So when you have the shorter wavelengths, it means they have higher frequency. But what do I mean by the frequency? That is one thing we need to define precisely today. So let's try to define what is a wave. Wave is a disturbance you produced. No matter it is in the water or when you are speaking, you are vibrating the air molecules. So they are the disturbance propagate in the space from one to the other one. And they are a very important concept of the wave. What do they propagate? They only propagate the energy, not the particles. So the wave only carry the energy away. They don't bring the particle away. The second thing is that they will move at the well-defined velocity. And this velocity is determined by the material. So for example, if it is in the vacuum, or in the air, in the water, or in the metal. So the wave velocity or the wave speed is determined by the materials. So these are very important things. First is that the wave propagation only carry the energy away, not the particles. But the particle is the property of the material. They will affect how fast the wave is propagated. And also, I'm going to show you a very important thing is that the wave propagation is independent of the motion of the individual particle. But let me try to clarify what do I mean independent. Which you mean there are two different kind of concepts. They are connected, but two different ones. The wave is moving, but they don't carry the particle away. So for example, if the particles is oscillate up and down, you will find out the wave propagate is actually to the right. So let me show you what happens. So if you try to vibrate a string, and this is the particle along the string, but you will find out the particle of the string is not moving to the right. The particle of the string is up and down. But you will find out the wave will be formed and propagate to the right. So that is what we mean by the wave. And how about the vibration? So if you try to define this more rigorously, vibration is a wiggle in time, but the wave is a wiggle in space and time which transmit the energy. So this is the difference between them. So now let's try to study about the properties of the wave. So when you see the wave, you will hear people saying these two words. One is the crest and one is froth. What is the crest? It is the highest point of the wave, and the froth is the lowest point of the wave. So you can, using the previous example, the string will vibrate up and down. So the crest is the highest point the particles can reach, and the froth is the minimum point the particle along the string can reach. So they are oscillating up and down within this range. This is the crest and the froth. The second quantity is the amplitude and the wavelength. What is the amplitude? So you can see the particle of the string will vibrate in between these two extremes, and the middle point is the balance point, and from the middle point to the crest is the so-called amplitude. But you can also understand in terms of from the middle point to the froth. So this is a description how strong or how big the vibration it is. Now, what is the wavelength? Wavelength is how fast the wave can propagate within a certain period of time. So the definition of the wavelength can be defined in terms of the distance between the two the contingent crest or the two froths. So this is definitely one frequency wavelength. This is another one wavelength. But actually, you don't necessarily have to use the crest and the froth. Actually, any point actually repeat itself. The distance traveled is the wavelength. So you can see that this point will come back to itself again. And now the distance traveled in between is also one wavelength. And the reason we use the crest example is because you can obviously see that these 2 points repeat itself. So this is the concept of the wavelength and the amplitude. So now when you try to study about the wave or a vibration, you need to give the people how strong, how vibrating of the motion of the particles. This is the motion of the particle, but wavelength is how fast of the wave motions. So that's the reason I say that they are different. They are connected together, but you can see these two different kinds of motion are separate because the motion of the wave is to the right, but the motion of the particle along the string is up and down. So now let's have a conceptual quiz. So if you have the distance between the adjacent peaks, what does it mean? It means this is the wavelength of the wave or the vibration. But I have not yet defined you what is the frequency of the period. So now in the future, when you try to describe the vibration and wave, you need to, for the vibration, the most useful quantity is the frequency, how frequently it vibrates. So frequency, I have not yet officially defined it, so don't worry about it. But the wave should be described by the frequency and how fast it propagates, and what is the amplitude and wavelength. So this reason we try to distinguish the vibration is simply the wiggle in time, but the wave is the wiggle in the time and the space, and they also propagate the energy. So now let me define what do I mean by the period of frequency. So the wavelength is the distance the wave repeat itself. Now the period is the time for one wavelength to pass through a given point. So for example, if you have the point in the space, which is the point A here, so now you will have a wave propagate through this point. So this particle, when the wave propagates through, they will first going downward and now going back to the equilibrium point and going up and back. So the time span from here to here is 1 period. So you can also you can define that the time it takes for one complete vibration. And now we can define the so-called concept of the frequency. Frequency is actually 1 over the period. So which means it is the number of the cycles per second. So this is the one cycle, the time spent for one cycle. And now this is the number of cycles per second. So they are reverse of each other. So that's the reason I say frequency is 1 over period. So once you know the period, you know the frequency. You know the frequency, you know the period.